So good afternoon everyone. So I am R.V. Kiran, Assistant Professor, Department of Mechanical Engineering, Chevrolet Engineering College. So I am dealing with the subject Metrology, third year, second semester. So today in this video lecture, I am going to explain about the limits and fits. So what are the basic ideas of limits and fits, and what are the introduction topics in the limits and fits. So first of all, metrology is a subject dealing with the study of measuring instruments. So it is highly classified as the study of measuring instruments only. So we have different types of measuring instruments. So be it a micrometer, a vernier calipers, or a dial indicator, any other thing. So these are all comes under the measuring instruments. So studying of these measuring instruments is called as metrology. So today we are going to see the introduction topics of the metrology, that is the limits and fits. So we need to define the need for limits and fits for a machined workpieces. So if you are taking the machined workpieces or a workpiece, you have to define the limits and fits of a solid workpiece. This was brought mainly by the inherent inaccuracy of the manufacturing methods. So we are using different types of manufacturing methods, and we can use different types of manufacturing methods for designing or producing a product. So in these manufacturing methods, there is a little bit of inaccuracy by adjusting the method. So that is called as inherent inaccuracy of manufacturing methods. And these are coupled with the fact that exactness of size was found to be unnecessary for most workpieces. So the exactness in the size was not found in the most workpieces. So this is defined by the limits and fits only. And then in order to function could be satisfied, so when a function can be satisfied, it should found some sufficient to manufacture a given workpiece. So it can be with the two permissible limits. So a workpiece can exist in the two permissible limits, that is a tolerance, this being the variation in size acceptable in manufacture. So a tolerance can be varied by its size which is acceptable in the manufacture. And similarly, where a specific fit condition is required between mating parts, that is mating workpieces, it is necessary to ascribe an allowance. So that is, a allowance is mainly a required function. So that is a required function between the mating workpieces. Here Mating workpieces means a pair that is used to join every time. So, for an example, we are taking the bolt and nut as the mating workpieces here. So, when we are taking the bolt and nut as the required minimum mating workpieces, it is necessary to ascribe an allowance, either positive or negative, to the basic size. So, that is, it is used to achieve the required clearance or interference, that is called as deviation. So a deviation may be achieved by a clearance or interference position only. So next is the role of metrology in design for manufacturing. So in the manufacturing industry or the production industry, which is used to design for manufacturing, what is the role of metrology? So what is the role of metrology in the design for manufacturing? So if you are taking it in the manufacturing aspect, there are these types of functional requirements. So there are 5 types of functional requirements in the design for manufacturing. So first one is the key functional requirements. That is, what are the basic needs of the industry? So what is the basic needs for the industry to be manufactured? So these all are evaluated in the design for manufacturing functions. So that is the key functional requirements. Next one is the fit between the mating parts. So in designing a mating part or a mating parts, we are going to see different types of fits, that is clearance fit, interference fit and transition fit. So in this sub classification is also there, but what are the fit is going, you are going to produce is you are going to fit between the mating parts. So that is also a major concern. Third one is the tolerances dimensions on mating parts. So what kind of tolerance is on the basic size and what are the dimensions of the mating parts. So these are all comes under the third section. And fourth section, manufacturing processes and sequences. So what are the different types of manufacturing methods you are going to be allowed? So you are going to make a made to product design. So this design of manufacturing is done by the manufacturing process and the consequences functioned in it. So what are the different types of sequences functioned in the manufacturing processes? So all these comes under the fourth criteria, and last one is the cost of manufacturing. So when you are going to the cost of manufacturing, this depends upon the product quality. If you are having a weak product quality, the cost of manufacturing is very less. But if you are going for a qualitative product, so if you are going to produce a qualitative product, you have to be cost more than the before cost, that is cost of manufacturing is increased than the previous one. So if the quality of the product increases, then the cost of manufacturing also be increased in the criteria. So these are the different types of key functions for the manufacturing aspect. So that is for the design for manufacturing aspect. So in this picture, you can also see the graph of the cost of manufacturing and the tolerance. can see it in the picture. So if the tolerance is higher in size, if the tolerance is high, the cost of manufacturing is also very high. But if the tolerance is used to decrease, the cost of manufacturing is also been decreasing. So you can see it in the graphical representation. So the cost of manufacturing decreases with the tolerance. So this is the basic graphical structure. Next one is the evaluation for the limits and fits. So for selecting a limit and fit, what are the basic factors you are going to work out? So that what are the steps involved in the evaluation of limits of tolerances? First one is the selection of an appropriate fit based on the functional required. So based on the function required, you need to select an appropriate fit. So depending upon the function, so depending upon the designed function, we are going to select this fit. Second one is the selection of type of shaft and hole. So what are the types of shaft and types of holes? So selection of the type of shaft and type of hole depends upon the types of fits only. So what are the deviations in the fits and what is the upper limit and what are the lower limit of the fits. Third one is the selection of tolerance grade for the shaft and hole. So there are different types of tolerance grade. So working standard and the working environment depends upon the tolerance grades only. So there are four different types of tolerance grades for the shaft and hole. So you need to select the one of the tolerance grade for the shaft and hole. Next one is the evaluation of standard tolerance. So what is the evaluation limit of the standard tolerance limit? So you need to define the what is a standard tolerance. So what are the different types of limits and in the tolerances and what are the different types of standard tolerance. And last one is the evaluation of the limits of tolerances. So what is the upper limit and what is the lower limit of the tolerances? You need to know all about the limits of tolerances. So these are all depends upon the evaluation for limits and fits. So coming to the standard short answers, that is, first one is the precision and accuracy. So coming to the precision, it refers to the repeatability of an element or repeatability of an element. So precision refers to the repeatability, that is the standardness, and accuracy refers to result to the true value. So that is it refers to the result of the true value. and this accuracy can be found by, so we have a formula here for the accuracy. So accuracy is equal to root of repeatability square plus systematic errors square. So what is meant by repeatability and what is a systematic error? So generally we had already discussed about the repeatability manner. So precision refers to the repeatability, but coming to the systematic error, it is the difference between the true value and the mean of set of readings. Mean means average, so average set of readings. So when you have to define a um, outside diameter of a shaft, you need to take 3 to 4 readings. So you need to take 3 to 4 different readings in 4 different positions. Then you have to average these number of set of readings. So you have to average the set of readings. So that is called as mean of set of readings. So these systematic error can be defined as the difference between the true value and the mean of set of readings. So that is defined by the accuracy. So accuracy means square of repeatability square plus systematic error square. So here in this picture, you can see the difference between the accuracy and precision. Accuracy and precision. This is a dartboard used for darting. So when you throw an arrow on the dartboard, you need to get some accuracy. So that is some accurate reading or some accurate darting. So in the first dartboard, you can see the multiple number of positions. So that is multiple number of darting elements produced in the dartboard. So the distance between each dot is high here. So that means it has less accuracy and less precision. So precision means the distance between the two darting elements, but the accuracy also is very less. So when you see the center mark, it has hit by only once, and the remaining 6 dartings have been varied. So ఇది ఒక పొజిషన్ లో మాత్రమే మనకి డాటింగ్ అనేది కరెక్ట్ గా ఫిట్ అయినమ్మా, మిగతావన్నీ కూడా చాలా దూరంగా పడిపోయినాయి మనకు మార్కింగ్ చూడండి. అందుకని ఇక్కడ లో యాక్యురసీ అని చెప్తాం. ప్రిసిషన్ అంటే మనకి ఒకే టైప్ ఆఫ్ ఎలిమెంట్, ఒకే టైప్ ఆఫ్ పొజిషన్స్ లో డార్టింగ్ అనేది జరగటం. సో ఇక్కడ డిస్టెన్సెస్ కూడా డార్ట్ కి ఒక డార్ట్ కి చాలా ఎక్కువ డిస్టెన్స్ ఉంది కాబట్టి మనకి ప్రిసిషన్ కూడా చాలా తక్కువగా ఉంది. సో దట్ ఈస్ low accuracy and low precision. And when coming to the second one, so the darting is done in the last point, last and but one last point, and but all the dots are in the same position. So here you can see the no gap between the darting points, but the point of accuracy is very less. So that is very less accuracy has been provided here, and high precision is done here because of the less amount of gap between the darting points. So that is called as high precision element. So these type of high precision elements can be done in the less distance between the darting positions. Third one is the darting has been done in gap. So you can see the red color picture here. So in the red color mark, there is only 2 number of points have been picturized. So only 2 elements have been pictured here. So the other elements have been done in the white board, so white chart. So that is a low precision, and all has been done in the meaner position only, that is in the high accuracy points only. So that is the third one, high accuracy and low precision element. So this kind of darting is done in high accuracy and low precision. And coming to the last one, all the darting points have been positioned in the red element, that is in the red color mark only, and the points are also in the less space, so lesser positions have been elevated. So these darting positions have been done in very less space, that is less. So this is called as high accuracy and high precision. So these have been done in the high accuracy and high precision elements. Next one, we are going to see the some of the terms and definitions of the limits and fits. So first one is the limits. So there are generally two extreme permissible sizes of dimension between which actual size of the dimension is contained. So when you are going to the actual size of a dimension and which is constrained, there are two different and two extreme permissible sizes of dimensions between these actual size of dimension which is contained. And there are two permissible sizes. First one is the maximum limit of size, and second one is the minimum limit of size. So first of all, going to the first one, maximum limit of size. So that is the greatest permissible size of a feature. That is the higher permissible size of a feature can be defined by the maximum limit of size. Second one is the minimum limit of size. These can be obtained by the smallest permissible size of a feature. The smallest permissible size of a feature can be defined by the minimum size of the limit, that is here the minimum limit of size. The next one, you can see it in the picture also. So this is the shaft required, and the green color mark shows the basic size of the shaft. So there is some gap between the maximum size and minimum size. So these engraved lines defines the gaps between the maximum size and the minimum size. But the basic size is different from the maximum size and minimum size. Next, the upper deviation. There are different types of deviations there. First one is the upper deviation, second one is the lower deviation, and third one is the fundamental deviation. So based upon these deviations, the tolerance grades have been divided. So in the first picture, the upper deviation, lower deviation, and fundamental deviation is on the red color line. So you can see the red color line here. So this red color line is indicated by the upper, lower, and fundamental deviations. And the second size, that is the fundamental deviation size, have been done in the black color line, that is the lower deviation and the upper deviation. So the lower deviation and the upper deviation sizes can be seen in the black color mark, which is an improved size. So that is an improved size of the limits. And next, the tolerance, international tolerance grade also have been varied. So the minimum size and maximum size have been increased than the shaft. So the minimum size and the maximum size have been increased larger than the shaft of hole. And next, coming to the tolerance. So this tolerance is a permissible variation in size or dimension. So this is the difference between the size or dimensions. So you can see the difference here, maximum size and minimum size. So these are all called as tolerance. And the minimum difference between the hole and shaft also can be cleared with the tolerance only. So that is the amount by which a job is allowed to go away from accuracy without any functional trouble. So without any functional trouble, you can see it or you can allow it to go for accuracy. So these are all about the limits and tolerance. And next one, what are the general terms used in the limits and fits? So what is the basic definitions used in the fits? So first one is the shaft. So this term is used according to the convention to describe the an external feature of a workpiece, including the features which are not cylindrical. So a shaft need not to be a cylindrical part, but all the minds in the students have been decided that a shaft is a cylindrical object. So but the features, including the features, these are not cylindrical. So a workpiece need not to be cylindrical in shape when it satisfies a shaft. That is the basic definition. So according to the convention, that is according to the usage, to describe an external feature of a workpiece, it is termed to be as a shaft. Second one is the hole. So according to the basic purpose, to describe an internal feature of a workpiece. So shaft defines the solid element of a workpiece, but hole defines the hollow creature, that is a hollow statement of a workpiece, which including features which are not cylindrical. So in the hole also, we are not assuming it as in the cylindrical shape. So we can see it in the square hole and rectangular hole or any other shape. So pentagonal hole, hexagonal hole, based upon the uses we can make it. So according to the convention, to describe an internal feature of a workpiece which does not features any cylindrical parts. Next one is the basic size. So the basic size is defined as it is the size with reference to the upper or lower limits of a size which are defined. So which are going to be determined. So the upper limits and lower limits can be clearly defined by the basic sizes. So the lower limit of a sizes can be defined by the basic size, that is also called as nominal size. Next one is the actual size. So the size of an actual workpiece can be obtained by his actual measurement only. So by defining the actual measurement of a workpiece, we need to define the actual size of a workpiece. So that depends upon the type of measurement obtained by the size of a feature, that is the size of a feature obtained by the measurement. And last one is the zero line. So the zero line is defined by the, it is a line along which represents the basic size, and zero for the measurement of upper or lower deviations. So for seeing the upper and lower deviations, the line which is representing the basic size and zero for measurement. So this is called as a zero line. Next one is the deviation. So the algebraic difference between a size so the algebraic difference between a size, that is the actual size or limit of size, so etc., and the corresponding basic size. So and the corresponding basic size can be defined by the deviation limits. So these deviation limits can be between the actual size or limits of size, that is in the zero line also. So the axis line is called as the zero line. And first one is the upper deviation. So the algebraic difference between the maximum limit of size and the corresponding basic size, that is called as upper deviation. So for representing the holes, we are using the capital letters. So for representing the holes, we are representing the capital letters, and for representing the hole, we are using the smaller letters. So that is the basic difference in the upper deviation of the shafts. So the algebraic difference between maximum limit of size, be it a hole or a shaft, be it a hole or a shaft. And the corresponding basic sizes can be seen as capital ES or small es. Es means the hole size and the small es means shaft size. Next one is the lower deviation. So the algebraic difference between the minimum limits of size. So it is the algebraic difference between the minimum limits of size. So that can be seen here both for both parts, that is the for both the mating parts, that is hole and the shaft. So for the both hole and shaft, we can see the lower deviations as the minimum limits of size, and these can be represented by, so these corresponding lower deviation size can be represented by capital EI for hole and small ei for shaft. So capital letters is indication for the holes and small letters is the indication for the shaft size. So that is about the lower deviation of the hole and shaft. And coming to the third type of deviation, that is the fundamental deviation. So the fundamental deviation is either one of the two deviations. So that is either upper deviation or the lower deviation. So it can be produced from any one of the two deviations, that is the upper deviation or the lower deviation. So it is one of the two deviations which is chosen to define the position of the tolerance zone. So it is one of the two deviations which is chosen to define the position of the tolerance zone. So that is called as fundamental deviation. And last one, we are coming to the tolerance. So what is a tolerance? So the algebraic difference between the upper and lower deviations. So that is called as a tolerance, and it is an absolute value. So the algebraic difference between the upper and lower deviations is called as a tolerance, and it is an absolute value for the tolerance gradings also. So we can divide the tolerance into tolerance grades. So based upon the types of tolerances, the tolerance grades has been evaluated. So these are the fundamental terms and definitions which we are seen in the basics of the limits and fits. So this is all about this video lecture. So we have seen the basic differences. So basic differences. So what is a limit and what are the fits to be measured parts. Next one is the role of metrology in manufacturing. So what are the different types of factors evaluated in the design for manufacturing process. Next, evaluation for the limits and fits. So the what types of limits and fits can be evaluated. So based upon the selected fits, we are going to design the limits and fits. Next one, we go to the different types of terms and multiplities, that is precision and accuracy. So we have seen the example. So a good example for the accuracy and precision, a dartboard, and the stamping on the dartboard. We have seen low accuracy, low precision, low accuracy, high precision, high accuracy, low precision, and high accuracy, high precision. Next one is the terms and definitions. So different types of limits have been seen here. That is maximum limits of size and minimum limits of size. And we have seen the different terms and different types of definitions in the general uses. That is the shaft, what is the hole, what is the basic size, and what is the actual size according to the zero line, and what are the deviations. There are three types of deviations, namely upper deviation, lower deviation, and the fundamental deviation. And last one is the tolerance. So by this, I'm ending this video lecture. In the next video lecture, I'm going to we are going to see the what is a fit and what are the types of fits. So different types of fits can be seen here, and what are the material conditions of all the fits and different types of grades there. Thank you for the class.